Right, Matrix, here is where we need the logs. This is where they're going to assess you. Now, I'm going to go very real world. I'm going to apply this into the real world. Now, in your notes, it says there's a colony. Okay, it's a colony of an endangered species, and that's quite tragic. There's some animal species like the rhinos. They often talk about the rhinos that are endangered species. This colony originally numbered, they started off with 1,000 animals, and they were predicted to have a population n after t as given by this equation. So the little formula to predict the population would be the number of animals given by, and this was 1,000 into 0.9 to the exponent t. Okay, and what's nice about that is that there's a formula to predict what it will be like, and hopefully we're not going to cause too much damage with these animals, okay, and cause them. And the first, and cause, pain to them and maybe extinction. Number A, estimate the population after 1 year. Okay, now remember, this endangered animals colony started off with 1,000. This is a formula to calculate the number of animals in the colony after a certain time period. T is time in years. Okay, now how does this work? No problem. All we have to do is we have to simply plug in 1 for t, that's after a year. And if we work out that, well, let's see, how many animals would we have? We should have about 900. So you'll notice that they're going down. Okay, it's terrible. This is an endangered species. It's going down after 100 animals died. Okay, so be very careful with this. The other thing that's important here is they said in number B, after how many years will the population decrease to 200? After how many years? After how many years? So we want T. After how many years will the population decrease to this amount? So remember, it's going down. It started off with 1,000 and it's going down. This is the formula we use. So what we can say is, okay, well, the formula for the population decrease of these animals is given by this. Okay, 0.09 t. Okay, now if we let that equal 200, there'll be 200 animals. That's the number. Now we want to find t, and here is where logarithms is going to be very valuable to you. Okay, well, firstly, if you look at this, we could possibly divide both sides by the 1,000 to just get rid of the 1,000 on the right. Okay, so if I do that, what do I get? I'm going to divide, and 200 divided by 1,000 is 0.2, and that the thousands cancel, and we're left with this. Now watch how brilliant this is. Now we use logs. We introduce the log of 0.2 to base 0.9 is equal to t. Okay, now if you plug that in your calculator, your t comes to 15,275, so it's quite a decimalized number, 275, and then 53, and it goes on like that. Now, if you think about that, that will be approximately about 15 years. So after 15 years, the population is going to be right down. So it's going to be about approximately 15 years. And if you take this decimal and you multiply by 12, this decimal, you multiply by 12, 0.27533 going on, use the one in your calculator, it will come to about 3 months to be exact. Okay, so it's just over the 15-year period that the population will drop to 200. Okay, very critical that. Okay, now another one, we're going to start going into financial maths. Now, you probably remember that up to now in grade 10 and 11, of course, we always worked with the compound interest formula. That was your starting amount, your accumulated amount for your interest, and then your time period. Now remember, we never solved for n in grade 11 and 12. We always solved for a, p, and I. Now how do we deal with that? Okay, now I'm going to give you an example. Shane invests. I'm going to write down some little numbers here, a, p, I, and n. This guy Shane, he invests 20,000. So he puts 20,000 Rand, that's his present value, into a bank account paying 8% annually. Now remember, it's 0.08. You divide by 100. Typical finance. And the investment's going to double, so it goes to 40,000. So we want the investment to double. Question is, how long would it take? And remember, we're working in years here. So, and it's compound interest. Okay, Shane invests 20,000 Rand into an account paying 8% interest per annum, compounded annually. So it's an annual interest rate. How long will it take for the investment to double, to reach from 20 to 40,000 Rand? Okay, now the question is, of course, we've got to find N, which you don't know how to do at this stage. But let's have a look if we plug the values in. Well, the accumulated amount is 40,000. The starting amount, the P, is 20,000. 1 plus your interest to the exponent N. Now we've got to solve for N. Well, this is easy. If you divide both sides by 20,000, 40,000 divided by 20,000 is 2. And then we're left with this. Okay, remember 1 plus 0.08 is this. Now look at this. We can use the laws of logs. This is where logs becomes very useful. The log of 2 to base 1,08 is n. And this is really where logs is going to be used. Not all those difficult applications, those sort of rules and laws. Okay, now if you work that out in the calculator, you're going to get n is going to be about 9,006468,342 going on. And if you want to, it's so close to 9, so it'll take about, let's say, about 9 years to double at an interest rate of 8% compounded annually. You can see now this is something that's in matric, is the use of logs to be able to determine the value of n in compound formulas. Okay, let's have a look at another one. Now watch out, matrics. This is where we bring in different compounding periods from grade 11. We've got here, it says how long, so I'm going to write this down. This is the second example. Now careful. It says there, how long will it take an amount of 150,000 to double? Okay, so we're going to double this again. If the interest rate is, now careful, it's 18% per annum compounded monthly. Okay, now be very careful with this. Remember, this is your R at the moment, but how do we get the I? So let's just write this down. We've got A as 300,000, no problem. The starting amount was 150,000. Now the interest rate is compounded monthly, so it's 0.18 divided by 12. Remember that when you're dividing by 12, you're compounding monthly, so you divide the interest rate by 12. Now, the N, I'm going to treat N, I'm going to multiply and go into months here. Okay, so N, if I multiply by 12, I'm going to get some months here. So if I apply this in the formula, I can say the number of months would be 12. Okay, if you think about it here, let's just quickly put our formula down. If we just clean that up a little bit there, we can say, well, what is that going to be? The A, which is 300,000, is equal to P. Now watch this. 1 plus the interest rate to the, now we're working in months, so we may as well put a month there, 12n. Okay, remember n is the number of years. So if we divide both sides by 150,000, we get this 1 plus 0,018 is 1,015. Okay, if you do it that way. And then we can simply say, okay, fine, that's going to be to the 12n. We're working in months. Apply the laws of logs. Log 2 to base 1,015 is 12n, and we're working in months here. Okay, so no problem. If you evaluate that decimal, what do we get there? We're going to get 12n is equal to the decimal 46,55552563. Okay, now that's the number of months. So if you divide by 12, you get 3,879 627136. So that would be about 3 years. And if you take that decimal there, multiply by 12, 0,879 multiplied by 12, it gives you almost 4 years. It'll take almost 4 years for the money to double at a compounded interest rate. So in financial maths, you're going to need to use logarithms big time with this. So just remember that carefully. And the sum of money doubles 18. Watch out for this. These animals here, they're very important. Monthly, half yearly. Okay, and then I multiply the n by 12 and I divide the I by 12. And keep by timesing by that, you're working with months.